Right, today's video is a continuation of the basics that we did in part 1. That's linked up there. Right, so here we have a trapezium, and there's a whole lot of vectors that have been given to us, and they're actually labeled on the diagram. And then it says E is the point on the line DB, such that DE is 1/3 of DB. It's our job to now find DE. As before, we don't have a direct route. We're going to have to divert to A. So we're going to go DA, and then from A to B. As before, we're going to add those two vectors together, but just remember, because we're going against the direction from D to A, instead of using 3B, we're just going to use negative 3B. Right, so now we have DB, but we need DE. And there's just one more step to find it. Just multiplying that vector DB by 1/3. So plugging it into that bracket, and then multiplying our bracket, we get that DE is minus B plus 4A. And because there's a part B, we're just going to store that up at the top for the time being. In part B, we have to find vector AE. So let's have a look. We again don't have A to E, but we do have a known vector, 3B, from A to D, and then we've just calculated DE. So we can just take those two vectors and add them together. Because we are now going from A to D and not against the direction, we can just use 3B as it is. So AE then becomes AD plus DE. Plugging those values in, we get AE is equal to 2B plus 4A. Right, here's our level up. If you want to give it a go, pause the video now. Right, so it's our job to now find vector OX. As you're used to by now, we don't have it. We need to figure it out from the various routes that we can travel to get there. One big clue that they've given us is that X is the midpoint. So we are probably going to use that in some way. Right, so here our job is to find OX. As in part 1, we actually have a couple of different routes that we could go to find OX. First, we could go from O to P, and then from P to X, or we could go O to Q, and then Q to X. For the sake of the video, we're going to choose this route. Looking at the route, we can see that we actually have OQ already, which is great. And it's going in the same direction, so I can use it as is. Now is the point that we run out of information, so we need to look around and see what we can get. We don't have QX. However, we could get QP, and then we know that X is the midpoint of that line. So if we found QP, we could simply just halve it. Let's have a look. To get from Q to P, we can't go directly there. However, if we go QO, which is negative 6B, and then OP, which is plus 6A, we've now got QP. Plugging it into our original formula and multiplying out our half, we just need to now collect those like terms, and we get OX is equal to 3B plus 3A. Once again, there's a part B, so I'm going to keep that up in the corner. Now they give us a little bit of information. They tell us OY to YX is in the ratio 2 to 1. So to get QY, we can go QO, which is a negative 6B, and then O to Y. QO is just our negative 6B. OY we don't have, but that's where that information comes in value. We know that we can split OX into the ratio to find OY. When splitting a ratio into a fraction, you need to remember the denominator is the total number of parts. So our denominator in this case would be 1/3, and we're interested in the OY section, so that would be 2/3 multiplied by my original OX. Plugging OX in and multiplying out our bracket, our final step is then just to collect our like terms. And there we go. We get QY is equal to 2A minus 4B. I hope it helped. Have an awesome day. Bye.